Hi, my name is Mark Parker. I'm a programming writer on the Lync product team. I write the documentation for the Microsoft Unified Communications Managed API SDK. In addition to my work on the UCMA SDK, I have written several technical articles about UCMA features. You can find these articles by searching MSDN for Lync 2010 Technical Articles. I'll give the URL at the end of this video. This video is associated with a set of articles titled Creating an Automated Attendant in UCMA 3 and Lync 2010. This set of articles was written jointly by John Austin, another writer on my team, and myself. The goal of the articles and this video is to show how to use the capabilities of UCMA and the Microsoft Speech Platform SDK to communicate with a Lync 2010 application. In the applications that John and I wrote, the UCMA application uses speech synthesis to speak a set of menu selections to the Lync 2010 user, who responds by pressing keys on a numeric keypad. During this video, I will be talking about the menu hierarchy and the prompts that are used, and will give a brief demonstration of the UCMA application. After that, I'll discuss the major points of the application, followed by concluding comments. Before we go into the details of the UCMA application, let's take a look at the menu and prompts that are presented to the Lync 2010 user. Northwinds Trading has three divisions: sporting goods, kitchen goods, and automotive parts and services. Each of these divisions is further divided into three departments, as shown in the next slide. Here we see the menu hierarchy and all of the prompts. This slide shows the greeting prompt and the first prompt, which asks the user to choose a division by pressing 1, 2, or 3. In this slide, we see what happens when the Lync 2010 user presses 1 for sporting goods. After the first key press, the second prompt plays, asking the user to choose one of the three departments in sporting goods. In this slide, the user has pressed 2 to speak to someone in the fishing and camping department. The application now informs the Lync user that the call is being transferred. For the sake of simplicity, the application code that is shown in this video doesn't actually transfer the call, but this is not difficult to implement using the begin transfer method on the call. The demonstration that we'll see next shows the information that the UCMA application displays in the console. After the call from the Lync user arrives, you will hear the synthesized speech that is played to the Lync user.
Welcome to Northwind Traders. Press 1 for sporting goods. Press 2 for kitchen goods. Press 3 for automotive parts and services. Press 1 for tires and brakes. Press 2 for automotive services. Press 3 for auto accessories. Transferring to automotive services.
Now let's take a look at how the application works. To save time, I won't go into detail about creating and establishing an endpoint. The endpoint used in the application being presented here is a user endpoint, as in many of the Quick Start samples that are included in the UCMA 3.0 SDK, including methods that are defined in UCMA sample helper.cs, a file that is included with the Quick Start samples. After the application creates and establishes an endpoint, it needs to register a delegate that will be called when an incoming call arrives. The register for incoming call generic method is used for this purpose, with type of call expected and the name of the delegate being specified. For this application, we're expecting an audio-video call, and the name of the delegate is audio-video call received. Next, we'll look at how the delegate should be written. The audio-video call received delegate needs to carry out three important tasks. 1. Cache the incoming call in a global variable. 2. register a handler for the audio-video flow configuration requested event. 3. Accept the incoming call. Here we see the code for the incoming call delegate, the audio-video call received method. In the first line of code, we obtain the call from the call property on the delegate's call received event args parameter. The stored value for the call is used elsewhere in the application. The next line shows registering a handler for the audio-video flow configuration requested event. This handler, which we'll look at shortly, caches the audio-video flow for the call. The flow will be used when we initialize two other components that are used in the application, the speech synthesis connector and the tone controller. The last line shows begin accept being used to accept the incoming call. The first parameter of this method is the name of a callback method, which is where the end accept method is called. The audio-video call flow configuration requested method is the handler for the audio-video flow configuration requested event. The main purpose of this handler is to cache the audio-video flow in a global variable. The flow property on the audio-video flow configuration requested event args parameter contains the flow for the incoming call. As already mentioned, the audio-video flow is needed for initializing both the speech synthesis connector and the tone controller. Creating a tone controller instance to detect key presses is straightforward. After the constructor is used to create a tone controller instance, the flow that was previously cached is connected using the attach flow method. The next line registers for notification of tone received events. Later on in the video, we'll look at the tone controller tone received delegate, which is called when a tone received event is raised. For now, we'll move on to getting set up for speech synthesis. Getting the speech synthesizer ready to speak prompts takes quite a few steps. To make the connection between the APIs in UCMA and the speech synthesis API in the Microsoft.speech namespace, some plumbing needs to be put into place in the form of a UCMA speech synthesis connector object. The speech synthesis connector object connects the flow of the call with the stream into which the speech synthesizer sends its audio output. Here are the steps involved. 1. Create a speech synthesis connector instance. 2. Attach the flow of the call to the speech synthesis connector using the connector's attach flow method. 3. Create a speech synthesizer instance. 4. Create a speech audio format info instance. 5. Set the speech synthesizer's output by using the set output to audio stream method. 6. Register for notification of speech synthesizer events such as speak started and speak completed. 7. Start the speech synthesis connector instance using its start method. In this slide, we see the code that prepares the application for performing speech synthesis. In the code shown here, I am initializing the speech audio format info instance to 16,000 samples per second, 16 bits per sample, and using monaural audio. The default encoding format for this constructor is PCM. Another of the constructor overloads lets you specify the encoding format as PCM, ALAW, or ULAW. The arguments to the set output to audio stream method are the speech synthesis connector object and the audio format. At this point, the speech synthesizer is ready to speak a prompt, which can be of the form of a string, a prompt object, or a prompt builder object. The first prompt that is spoken to the user conveys a welcome message and then lists the three divisions of Northwind traders: sporting goods, kitchen goods, and automotive parts and services. The user will be directed to one of these divisions by pressing 1, 2, or 3. As you can see from the code shown in this slide, the prompt builder prompt is built up gradually, with breaks appended to the prompt to make it sound more like natural speech. In normal operation of the application, the user hears the first prompt and then responds by pressing a key on the number pad. This causes the tone received event to be raised, which in turn causes the tone controller underscore tone received method to be called. Because the user needs to press two number keys to navigate through the menu hierarchy, the tone received event handler is normally called twice. A global variable, underscore cached tone, is used to store the first key press and to determine whether the handler has been called before. If the handler has previously been called, the logic in the event handler retrieves the new tone and uses the new tone and the cached tone from the previous call to the event handler to prepare a transfer prompt, telling the user which department the call is being transferred to. This slide shows the code for the tone controller underscore tone received method, the handler for tone received events. What the handler does depends on the value of a global variable named underscore cached tone, which is initially set to no tone. If the value of underscore cached tone is no tone, then this is the first invocation of the handler. In that case, the tone is retrieved by evaluating the tone property on the handler's tone controller event args parameter. The tone is then stored in underscore cached tone as well as in a local variable named new tone. At this point, a prompt is prepared asking the user to select one of the three departments in the division that is indicated by the first key press. After the prompt is prepared, it is played. If underscore cached tone has a value other than no tone, then the handler has been called for the second time. In this case, the handler can retrieve the most recent tone, and with it and the previous tone, can now determine the department to which to transfer the call. Before exiting, the handler resets underscore cached tone to the value no tone. One more comment. The user is not forced to listen all the way through each of the first two prompts, and can press a key before the prompt is finished. If a prompt is still being played when the handler starts, the call to the speak async cancel all method cancels the prompt. After the final transfer prompt has been played to the user, the application begins shutting down. The steps involved are 1. Stop the speech synthesis connector. 2. Detach the flow from the speech synthesis connector. 3. Terminate the call. 4. Terminate the conversation. 5. Unregister the delegate that receives calls. 6. Shut down the collaboration platform. This slide shows some of the code that is used for shutting down the application. A keen-eyed observer might notice that the code shown here, 1. Stops the speech synthesis connector, 2. Detaches the flow, 3. Terminates the call, and 6. Shuts down the platform using the shutdown platform helper method in UCMA sample helper.cs. However, there is no mention of 4. Terminating the conversation or 5. Unregistering the delegate that receives calls. The reason for these omissions is that some of the actions described in the previous slide are occurring in callbacks that are shown in the next slide. The process starts when begin terminate is invoked on the audio video call. The callback parameter, call terminate CB, completes the termination of the call by invoking the audio video call's end terminate method. The other things that happen are discussed in the next slide. In this slide, we see the code for two callback methods, call terminate CB and conversation terminate CB. The call terminate CB callback method completes the termination of the audio video call instance by invoking the audio video call's end terminate method. This callback also starts the process of termination for the conversation by invoking the begin terminate method on the conversation. Notice that the callback parameter in this begin terminate invocation is conversation terminate CB. In the code for the conversation terminate CB callback method, we see that the process of terminating the conversation is completed with the call to the conversation's end terminate method. We also see the unregister for incoming call method being used, so if an audio video call arrives, the incoming call delegate will no longer be used. Thank you for taking the time to view this video. I hope that I have succeeded in my goal of showing how you can incorporate DTMF tone recognition and speech synthesis in your UCMA 3.0 application. A more comprehensive discussion of the application presented in this video is available at the link shown here.